Hi everybody. So in this video, we're going to look at calculating conditional probabilities using tree diagrams. So we're going to work through 5 questions, and if you want to work along with me, you can download a copy of this PDF from my website. I'll leave a link below. So for our first question, we're told that a student plays 2 games of tennis, and the probability that she wins the first game is 3/5, and if she wins the first game, the probability that she wins the second is 7/10. If she does not win the first game, the probability that she wins the second is 3/8. And we've been asked to complete the tree diagram. So we've got the tree diagram here, and we're told that the probability of winning is 3/5. So we can work out the probability of losing as 2/5, because winning and losing are mutually exclusive, they must add up to make 1. Then if we win the first game, we're told that the probability she wins the second is 7/10. And this will be 7/10. This will also be a win, which means it would be 3 times that she loses. But if she does not win the first game, the probability that she wins the second is 3/8. So she loses the first game, and then the probability of her winning the next one, we have 3/8. Then we have losing the second game, having lost the first, would be 5/8. So that's a tree diagram. Find the probability that the student wins both games. So if we identify this path, this would be a win followed by another win. So the probability of a win and another win will be 3/5. The and means multiply by the 7/10. So this will be 21/50. Okay, let's try another question. So now we're told now the probability that it snows on a Wednesday is 0.4. And if it snows on a Wednesday, the probability that it snows on a Thursday is 0.8. If it does not snow on a Wednesday, the probability that it snows on a Thursday is 0.3. We've been asked to draw and label the tree diagram, and then to find the probability that it snows on exactly one day. So do you want to try this question yourself? Okay, so how did you get on? Well, if we label this one as Wednesday, and the next set as a Thursday, and we'll have snow and not snow, we'll do this for both, then we're told that the probability of it snowing on a Wednesday is 0.4, which means it not snowing on a Wednesday will be 0.6. And if it does snow on a Wednesday, the probability that it snows on a Thursday is 0.8. So now we'll go here, which means not snowing will be 0.2. And if it does not snow on a Wednesday, the probability that it snows on a Thursday is 0.3. So not snow and snow is 0.3, which means this one's going to be 0.7. That's the tree diagram. For part B, find the probability that it snows on exactly one day. So this could be the probability of a snow and a not snow. So Wednesday it snows, Thursday it doesn't. Or the probability of not snow on a Wednesday, followed by snowing on a Thursday. So if we identify these paths, we've got snows on Wednesday, but not on Thursday. Which would be 0.4 multiplied by 0.2, put this in brackets, or then we've got not snowing on a Wednesday, so it must snow on a Thursday. So this would be the 0.6 multiplied by the 0.3. Well, this will work out to be 0.08, and this works out to be 0.18. When we add these two together, we get 0.26. So this will be the probability of it snows on exactly one day. Okay, how did you get on with that? Let's try another question. Okay, so in this question, we're told that a box holds 7 red beads, 4 blue beads and 3 green beads. And then 3 beads are drawn at random, one after the other, with no replacement. So no replacement is what makes it conditional probability. Find the probability that the first 2 beads are blue and this green. So do you want to try this question yourself? Okay, so welcome back if you had a go. So rather than drawing the complete tree diagram, we want the probability that the first 2 beads are blue. And we can see that we've got 4 blue beads. So in our first go, we've got 4 out of a possible 14 beads. And then in the second go, she's taken out 1 blue already, so there would be 3 left. And there would be 1 less bead because it hasn't been replaced. So that would be 3/13. So you've got a probability of a blue on the first go, probability of a blue on the second, and then we're told that the third go, we get a green bead. And at the beginning, there were 3 green beads, and none of them have been taken. So the probability of a green on the third go will be the 3 original, but now there'll be 2 less beads in total, so this will now be over 12. So the probability of a blue followed by a blue followed by a green will be 4/14 multiplied by the 3/13 multiplied by the 3/12. We can work this out and we get 3 over 182. Okay, let's try another question. So in our final question, we're told that a jar contains X marbles, 7 of the marbles are red, and Emma picks a marble at random from the jar and does not replace it. Liam then picks a marble from the jar, and the probability that they both pick a red marble is 0.2. We've been asked to form an equation involving X and then express it in this form. And then for part B, to solve the equation. So do you want to try this question yourself? Okay, so welcome back if you had a go. So we're told that the probability that they both pick a red marble is 0.2. So we want the probability of a red followed by a red equaling 0.2. So if we begin with Emma, the probability of her picking a red would be the 7 out of X in total. So 7 over X. Then the probability of Liam picking a red, well, if Emma picked a red, there'll be 1 less. And there'll be 1 less marble in total as well. So 6 over X minus 1. And because these two events happen one after the other, 7 over X multiplied by 6 over X minus 1, so a red and a red, must equal 0.2. We can multiply the numerators, and we get 42. For our denominators, we get X multiplied by X minus 1, and this must equal 0.2. We'll move this denominator over to the right-hand side, and we'll expand out them brackets. So we've got 42 will equal the 0.2, which is 1/5 of X squared minus X. And then we can multiply both sides by 5. So we've got 210 will equal X squared minus X. And then we'll make the equation equal 0. So X squared minus X, moving this 210 over to here, will give us a 0. And this is the equation that we were asked to find. And then for part B, to solve the equation, well, we can factorize this. So we'll have X minus 15 multiplied by X plus 14. And this will equal 0. So X must equal 15 or X must equal negative 14. But we can't have negative 14 marbles. So X must equal 15. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link below.